Hey, we are still in chapter 5, and now we're in section 5.3, dividing polynomials. The truth of the matter is this whole section goes through a lot of examples very quickly, and you'll probably need a couple more examples. Feel free to ask questions. We only have one vocabulary word, which is synthetic division, which is a style of dividing that we're going to talk about later. So I'm not even going to define this at this time, but synthetic division is going to be really popular in the next couple of example problems. So let's get started. So we're dividing polynomials, which means this is written as a fraction, and when we divide, we're making sure we're seeing how many times one number goes into another number. So I want you to think about this. Think about this expression, this division problem, this quotient, if you will, as 4x cubed times y squared over 4xy. And notice that everything needs to be divided by that denominator. Plus this, you see where I'm going with this. So I'm dividing everything, every term in the numerator by my denominator of 4xy. And there. Perfect. And so now it's a matter of simplifying these monomials in a sense, right? This monomial divided by this monomial, this divided by this, and this divided by this. 4 goes into itself 1 times. X goes into x to the third power. Well, you remember from your rules in section 5.1, x to the third power divided by x would leave us with x to the second, because like there's a 1 here. 3 minus 1 is 2. Y to the second power over y to the first power would just be y, and so this has turned into this. Following along, 4 goes into 8 2 times. These x's cancel one another out, and we're left with a y, and actually there's nothing in the denominator, so no need for that. And then we have subtracted by 4 goes into 12. 3 times x goes into x squared, x times, and y goes into y to the third power, y to the second power. So we end up with x squared, y plus 2y minus 3xy squared. And that's it. So not too bad. Remember, when we're dividing the divisor into each of the terms in the numerator. Let's take a look at example 2. In example 2, we're going to try something. It's the division algorithm. You remember back in the day when you had to do long division, something like 3 goes into, I don't know, 242. And so you take 3 and you say, can 3 go into 2? And the answer is no. Then 3 goes into 24. How many times 8? Multiplying. You get that. Subtract. Can 3 go into 2? No. And 0 times 3 is 0. Subtract and you get this, and you might have it as a remainder of 2. Or if you were really sophisticated, you could keep going by putting a decimal here, dropping some zeros and continuing on, blah, blah, blah. Or you could take the 2 and put it over 3 and say your answer is 80 2/3. My point in bringing you back down that sad memory lane is that we're actually going to do the same thing, but this time with polynomials. So we set up our situation with the division bar like that, and we do z minus 4 on the outside. That is our divisor, and our dividend is z squared plus 2z. I'm going to put some lines in these z's so I don't get confused with my 2's, minus 24. And so what you do is you ask yourself, how many times does z go into z squared? So in a sense, you're dividing z into z squared. And you get z times, correct? Because we can cancel out a z, we're left with 1z. Z goes into z squared, z times, so I'm going to put the z over here, and now I'm going to multiply both of these terms by z. So z times z is z squared, and z times minus 4 is a minus 4z. And just like you would when you were subtracting or when you were dividing regular numbers, right? When we're doing long division, you would subtract what you get, what the product of this number times the divisor. And when you subtract that, negative, and a negative here is actually going to be a positive. So this actually is a plus 4z. So this becomes positive 4z plus 2z, which is 6z. And when I subtract these two, they go away. And then I bring down the next term, minus 24. And then I ask myself the same question again. How many times does z go into 6z? So I'm asking myself, how many times does z go into 6z? And hopefully you see that the answer is 6. So, and it's a positive 6, so I put a plus 6 right here. And I multiply 6 times that z, and I get 6z minus 24. And I'm pretty happy because as I do my subtraction, everything cancels out. I have no remainder, and so my answer is z plus 6. So the quotient, that's the answer you get when you divide, is z plus 6. The quotient of this is z plus 6. All right. The next thing we're going to do is work on this quotient remainder situation with a multiple choice situation. So what we have is, looks like we're multiplying, but you see this negative exponent tells me to drop it into the denominator. So I'm going to do that by taking t squared plus 3t minus 9, and I could write it over 5 minus t, right? Because 5 minus t is to the negative first power. And we remember when things are being raised to a negative power, if it's in a numerator, we've got to drop it into the denominator. And if it's in the denominator and it's negative, we lift it up into the numerator. And that's something we'll talk about again later. So anyway, I don't need the 1 there. I'm just going to leave it as 5 minus t. So this is the same thing as this. And so now I know when I see something like that, I've got to do some division. So let's go ahead and do the division we need to do. So we've got 5 minus t on the outside, and we're dividing it into t squared plus 3t minus 9. How many times does, now this is written a bit oddly, to be honest, but we'll manage it. We're going to actually follow along with the t. I might actually rewrite this. It's okay. I may actually rewrite this as negative t plus 5. And I'm going to put t squared here plus 3t minus 9. Hopefully you can see that these are exactly the same problem, just writing it in a different way. How many times does negative t go into t squared? So I'm dividing negative t into t squared, and it goes negative t times. So I'm going to put negative t right here. We're going to start off, and I'm going to multiply this negative t times this term here. Negative t times a negative t is a positive t squared. Negative t times a 5 is a minus 5t. And remember last time, we have to subtract. So when I subtract, all of the signs will change within the parentheses. So this is actually a positive 5t, and I end up with a positive 8t. These guys cancel each other out, so they are no more. And of course, just like with long division, I'm going to drop this negative 9. Now I'm going to ask myself, how many times does negative t go into a positive 8t? So I'm thinking about this, and I see that it goes in negative 8 times, because a positive divided by a negative is negative, and these t's cancel out. So I've got a minus 8 here. Minus 8 times all of this is going to give me a negative 8, no, actually a positive 8t, because that's a negative times a negative, and then this negative 8 times that positive 5 is going to give me a negative 40. Again, I'm subtracting, and when I subtract, I'm going to get, this 40 will change to a positive 40. These guys cancel out, and this positive 40 minus 9 will leave me with a positive 31. Now, what do I do with the remainder? You remember that last problem where I think we had like 3 divided into 242, and I came up with the answer of 80 and 2/3, and the 2 came from the remainder at the end of the problem? Well, what we do with our remainder here, we took the 2 and we put it over the divisor. We're going to do exactly the same thing here. We take our remainder and we put it right over the divisor. So I can put plus 31 over negative t plus 5, and I'm going to write that down here. So I'm saying the answer is negative t minus 8 plus 31 over negative t plus 5. Now you might see something strange as we look at the answer choices, because none of them look like this exactly. But there is one that's exactly the same thing, but we just need to make sure we know which one it is. So this answer is clearly not is not right. This answer is not right, because it's a negative t and a negative 8 we got. It's out of this one and this one. So what we need to do is make sure that we are dealing with the right thing. So I'm looking at this plus sign looks similar here, but the 5 minus t, is this denominator, negative t plus 5, the same as 5 minus t? I hope you're looking at it and you see that it indeed is the same thing. This guy, this minus sign is not correct. and 5 minus t would be the same thing in terms of the denominator. So this is the one that we want. I know that was a little confusing and not clear. I will happily explain it a little bit better as to how we got C as the answer, but that's what we did. So we did long division and we got C. I'm going to go back over this really quickly. I want you to notice that we had to utilize our understanding of exponents and recognize that this term was actually dropped into the denominator. When I can write something as a fraction, I know that that's another way of talking about division. So this is a quotient. Really, I'm dividing t squared plus 3t minus 9 by 5 minus t. Over here, I had 5 minus t divided into this. I chose to write this t term first as a negative t plus 5 instead, just because that's just the way we were used to doing it in the last problem, and we usually ask ourselves how many times does the variable term go into the trinomial or the polynomial that we're dividing it into. And really it went just as we had before. Only difference is that our denominator looked a little bit different from our answer because we made that switch. All right, let's take a look at synthetic division. This is actually a really fun type of division to do, if there's anything called fun division. So the fun thing that we're going to do is actually not use all these variables, and it's going to make life a little bit easier. First, maybe I should do the problem long ways. Yeah, let me do that. First, I'm going to do the problem the way we would if we were doing long division, just for kicks and giggles. And then I'll go back and I'll show you how synthetic division works. And if this takes me too long, I'll just do another video and just add and call this part 1. Let's see if I can do it without that. Well, x goes into 5x cubed. I think I wrote the wrong thing here. X goes into 5x cubed, 5x squared times. So I'm going to put the 5x squared up here and multiply both terms by 5x squared. So 5x squared times x is 5x cubed, and 5x squared times a negative 2 is a negative 10x squared. Okay? Remember, we subtracted this point just like we would any ordinary long division. These guys cancel out. Negative and a negative becomes a positive. So this is actually a plus 10x squared. And so negative 13x squared plus 10x squared is going to lead me to a negative 3x squared. Bring down your next term, which is a plus 10x. I'm going to ask myself, how many times does x go into negative 3x squared? It goes in there negative 3x times, because negative 3x times x gives me a negative 3x squared. Well, you know what I'm going to do? I'm going to multiply each term by this negative 3x. So here I get negative 3x squared, and then I get a positive 6x. And of course, put it in parentheses and subtract. When I do that, these guys cancel out, which we can expect. That's been the pattern. And then I subtract out this guy over here, and I get a negative 6x and a positive 10x, which gives me a positive 4x. Dropping the last term down, negative 8. X goes into 4x how many times? Positive 4. 4 times x minus 2 is going to give me 4x minus 8 when I multiply 4 times x and 4 times negative 2. I'm going to subtract this whole thing, and you see everything cancels out beautifully, and I have no remainder, and I get a 0 down there. That's pretty cool, right? Now, if you thought that was cool, check out what we're going to do now. So this was the algorithm using the division algorithm. That's what this was over here. And so over here, we're going to do something called synthetic division. So synthetic division can only happen when we have x and a single variable and a minus or a plus another variable. So we need to have a coefficient of 1 here for the x, and then we can do the thing. So what would make this 0? What value of x would make this 0? And that value is a positive 2. So I start off with a positive 2, put it in, kind of mark it off, and I'm going to write the coefficients of each of the terms in that I'm dividing. So I write 5, negative 13, positive 10, and a negative 8. And the first thing I do is I just drop the first term. I write it down here. The next thing I'm going to do is multiply 2 times 5, and I get a positive 10. I'm going to add these two together. Negative 13 plus 10 is a negative 3. I'm going to do 2 times this negative 3, and I get a negative 6. Add those guys together, I get a positive 4. 2 times 4, I get a positive 8. Add those times together, I get a 0. Notice that these are the coefficients of the answer. Dope, right? So what I know is